Writing linear equations and using finite differences to find the rate of change. As we're given a table with a set of values, it asks us to find the 54th term in the following pattern. Your pattern becomes the value of the term. The first value in this term is 5. When x is 1, y is 5. The second number in the term is 8. When x is 2, y is 8. From a table, we have been practicing to find the rate of change. In order to determine the rate of change, which is delta y divided by delta x, between each ordered pair on the table. Pause your video now to find your rate of change. Between 5 and 8 is a plus 3, 8 and 11 is plus 3. 3 divided by 1 is 3. You take the 3, which is your coefficient. The coefficient is any number in front of a variable. 3 times 1. The reason we're going to multiply by 1 is because that is the value of the x. 3 times 1 is 3. We need to ask ourselves, what value do we need to either add or subtract to get to a value of 5? Our value is 2. Follow the same process for each row of the table. As we look, 3 times 2 would be 6. When we add the same 2, we get 8. 3 times 3 is 9. We add 2, we get 11. 3 times 4 is 12. Plus 2 gives us a value of 14. In order to find the 54th term, we're going to take 3 times the value of 54, because 54 is the value of x, and we're going to add 2. 54 times 3 is 162. When we add 2, we get an answer of 164. The 54th term in the sequence is 164. We can put our points on a graph. We notice that the graph is linear. We know it does not go through the origin, and it has a positive rate of change because as we move across the graph from left to right, the y values are getting larger. My rate of change is 3. My coefficient is 3. Your coefficient is the rate of change. The constant is plus 2, and it's always the same for each row of the table. Our equation is y equals 3x plus 2. As we look at table B, the pattern is 2, 0, negative 2, negative 4, negative 6. Those values go in the y column. Pause your video now to enter your points in and determine your delta y over delta x. Your delta y is negative 2. Your delta x is 1. Your rate of change is negative 2. We take negative 2 times 1, which is negative 4. In order to get an answer or a value of positive 2, we must add 4 to the process. If we continue all the way down, the 62nd term has a value of a negative 120. As we plot our points, we can see that our rate of change will be negative because as the value of x increases, the value of y decreases. The rate of change is negative 2. The coefficient is negative 2. The constant is plus 4. And it is the same for every row of the table. Let's look at finite difference C. Since the table is filled in for us, our first job is to find our rate of change. 8 divided by 2 is 4. So our rate of change, or our coefficient, is 4. We'll take that 4 times each value of x. In the first row, the x is 1. 4 times 1 is 4. We have to subtract 2 in order to get a value of 2. 4 times 3. On the second row, we're going to use a 3 in the parentheses because that is the value for x. 4 times 3 is 12. When we subtract 2, we get a value of 10. Your equation is y equals 4x minus 2. If we were to graph this, it would be in a positive direction because the 4 is positive. The minus 2 has no effect on which way the graph faces. Let's look at finite's difference D. The change from 2 to 12 is 10. The change from 1 to 3 is 2. 10 divided by 2 is 5. As you look further down the table, the change from 22 to 37 is 15. The change from 5 to 8 is 3. When you take 15 divided by 3, you get 5. No matter which points we go between, the rate of change between any 2 points on the table is always 5. The 5 becomes our coefficient. So if we take 5 times 1, that's 5. We need to subtract 3 to get a value of 2. We'll take 5 times 3. Again, we're using 3 on the second row because that's the value of x that they give us. 5 times 3 is 15, and 15 minus 3 is 12. Your equation is 5x minus 3 is equal to y. As we look at finite's difference E, we get a coefficient of negative 2 and a constant of positive 7. All of our delta y's divided by delta x simplify down to negative 2. The values in this table represent a linear proportional relationship, and the answer is false. While the graph is linear because it has a constant rate of change, the value of y when x is 0 is the number 7. So this graph does not go through the origin. As we fill in finite table F, please pause your video to find the rate of change on your own and then check it with me. Your rate of change should be 3. Use your rate of change to fill in the process column in your table and then check with mine. We take 3 times 1, which is 3, and we need to subtract 2 to get to 1. 3 times 2 is 6, minus 2 is 4. 3 times 5. Please note that the third row has a 5 for the x and not a 3, so make sure you're using the right values. 3 times 5 is 15, minus 2 is 13. As we continue down the table, we get 3x minus 2 in the process column. Our equation is y equals 3x minus 2. The coefficient is 3. The constant is minus 2. It is false that this is a linear proportional relationship. While the graph is linear because we have a constant rate of change, it is not proportional because when x is 0, y has a value of negative 2. So this graph does not go through the origin. It's now time to begin your homework. Please look back at the video if you have any questions.